Welcome back to class. In the first part of this chapter 11, we talked about the derivation of the IS curve. So in the second part, we want to talk about the money market and the LM curve. Real money supply is given by the ratio nominal money supply over the price level. There is a bar above nominal money supply because nominal money supply is an exogenous variable which is chosen by the central bank. Also, the price level P is exogenous because prices are predetermined. Real money supply. What is that? Let's try to gain some intuition about what real money supply implies. In our LOLEC and BOLEC example, it was the case that nominal money supply was equal to 4 euros. The price level was equal to 2 euros per beer. So real money supply in this example is equal to nominal money supply divided by the price level, 4 euros divided by 2 euros per beer, it's equal to 2 beers. The real money supply, which is in circulation in this situation, it is large enough to buy 2 beers. So we are setting nominal money supply in relation to the price level in order to find out how large is money supply in real terms, how many goods can be bought by this level of money supply and this level of the price level. In this graph, money supply is a vertical line. So in a first step, we want to work in a diagram where we have the interest rate on the vertical axis and real money balances on the horizontal axis. Money supply does not depend on the interest rate, and therefore it is a vertical line. If you want to, in our LOLEC and BOLEC example, it would be the case that we have a 2 here because the real money supply is equal to 2, and hence this line will start at the level of 2 and does not depend on the interest rate. Real money supply curve is a vertical line. You can already see in this diagram that the curve, which represents liquidity demand, is downward sloping and depends on the interest rate. So let's have a look on the money demand side. In equation 24, it is said that money demand is a function of the interest rate. And in the first part of this subchapter, it is mentioned that money demand depends in a negative way on the interest rate. So in case that the interest rate increases, then the opportunity cost of holding money increase and money demand decreases. The higher the interest rate, the lower money demand. So a negative relationship between money demand and the interest rate. At a later point in the textbook, it is the case that liquidity demand also depends on the GDP level. And I would like to introduce this second relationship already here. So money demand varies negatively with the interest rate. The higher the interest rate, the lower money demand. And money demand varies positively with the income level. The higher the income level, the higher money demand. Why is that? In a situation where GDP is relatively high, a lot of transactions have to be performed, and therefore the households demand a lot of money. Money demand is higher in case that the GDP level, the income level Y, is higher. In the last part of this chapter, we also can see a numerical example for the liquidity demand function. So on page number 331, we get this numerical example, y minus 50r. And hence it is indeed the case that money demand increases on a one-to-one basis in case that GDP is up, and there is a negative relationship between money demand and the interest rate. The higher the interest rate, the lower money demand, because there is a negative sign in front of this coefficient. This 50 implies when the interest rate increases by 1 unit, let's say from 4% to 5%, then it will be the case that money demand decreases by 50 units. Since there is a negative relationship between the interest rate and money demand, it is the case that when the interest rate increases, then money demand decreases. There is a negative relationship, and therefore the real money demand curve is downward sloping in this interest rate real money balances diagram. Of course, the equilibrium in the money market will be where the supply curve and the demand curve intersect. So with this model we have at hand here, we can determine the equilibrium interest rate. So this money market model is good to determine the interest rate in equilibrium. What happens if the market is not in an equilibrium? Let's assume that we are in scenario A, and it is the case that the interest level RA prevails, so that money supply is at the level A prime. This is the level of money supply, but money demand is larger. At this interest rate level, it is the case that money demand is at the level A. So in this situation, it is the case that money demand is larger than money supply. And here it is already indicated in this graph that this will lead to a situation where the interest rate increases, so that in the end, the equilibrium level of the interest rate will prevail. But why is it exactly that the interest rate increases? Let's have a look on the next slide and the line of argumentation. In the book, it's a little bit unclear. It said in case that money demand is larger than money supply, the households obtain money by selling bonds. It's just one sentence on this page, so let's go into detail. In scenario A, money demand is larger than money supply. The households say, we want more money. Money demand is larger than money supply. Where can the households get money? They can sell bonds at the bond market. So the private households are walking to the bond market. They are selling bonds. So on the bond market, supply of bonds will be larger than demand for bonds. This leads to a decrease of the bond price, and decreasing bond prices implies that the interest rate, the return on this bond, increases. Afterwards, the increase in the interest rate decreases money demand, which is indicated by these little arrows here. So when the interest rate increases, it's the case that money demand decreases until we reach an equilibrium here where supply and demand intersects. So this is the line of argumentation related to the adjustment process in case that we start in a disequilibrium. In case that money supply decreases, then it will be the case that the money supply curve shifts to the left, and this leads to an increase of the interest rate. So in case that the central bank performs a contractionary monetary policy and decreases nominal money supply, then also real money supply decreases, the money supply curve shifts to the left, and the interest rate increases. You can see that here with the labels. In the initial situation, in the blue situation, nominal money supply is on the level M1, and then nominal money supply decreases to the level M2, and therefore real money supply is lower, and in the second situation the interest rate is higher. In this subsection we want to derive the LM curve, and we will use this diagram to derive the LM curve. The LM curve will also be created in a diagram where we have the interest rate on the vertical axis and the output level on the horizontal axis. In the initial scenario, we are in the blue scenario, so interest rate is on the level R1. The blue money demand curve is valid. In the blue situation, the GDP level is on the level Y1 and the interest rate is on the level R1. So we have one combination of the interest rate and the income level where the money market is in equilibrium. So we can insert one point here in this interest rate income diagram, this blue point, which symbolizes one combination of the interest rate and the income level where the money market is in an equilibrium. So we have found already one point on the LM curve. Then we want to find out what happens if income increases. When income increases, it is the case that this affects money demand side. Money demand is higher than before, and therefore an increase in income raises money demand and shifts the money demand curve to the right. Now the red money demand curve is valid, and we can see in this diagram that the interest rate increases. The interest rate increases to the level R2, and hence we have a second combination of the income level Y2 and the interest rate level R2, where the money market is in an equilibrium, and then we can combine these 2 points, the blue one and the red one, and we can draw our LM curve. What's very important here is that the LM curve is upward sloping in this interest rate income diagram. What about shifts of the LM curve? Like right now, we only focused on this first characteristic, that the LM curve is upward sloping. What kind of factors lead to a shift of the LM curve? Here in this slide, it is mentioned that when the central bank decreases money supply, it is the case that this vertical money supply curve shifts to the left, and this leads to a higher interest rate level. And hence, decreases of money supply leads to an upward shift of the LM curve. You can see it here, that this was the previous LM curve, the blue line. When the central bank decreases money supply, the interest rate increases to the level R2, and hence the LM curve has to shift upwards. The LM curve has to shift to this red LM2 curve, and hence a reduction in money supply will shift the LM curve upwards. In section 11.1, we talked about the IS curve and derived the IS curve. In section 11.2, we derived the LM curve. So the next step is to combine the IS and the LM curve, and we are going to combine it in the interest rate income diagram. So we are in section 11.3. We are combining the information we gained from 11.1 and the information we gained from subchapter 11.2. The LM curve is upward sloping in the interest rate income diagram, and the IS curve is downward sloping. So here, for the first time, we can determine the GDP level and the interest rate level simultaneously. So we have one model where we can determine two endogenous variables. The interest rate will be endogenous and the income level. In this section, it's also the case that we once more have a look at the equations. So let's also perform this task and have a look at the IS relationship. On the left-hand side, we have goods supply, and on the right-hand side, we have goods demand, which depends on the consumption function, the investment function, and government spending. In equation 28, we have on the left-hand side real money supply, and on the right-hand side real money demand, which depends on income in a positive way and on the interest rate in a negative way. Let's have a look at the numerical example, and I think that this makes it a little bit more clear what the model is all about. So once more, we have the two equations here, and then in this numerical example, it is mentioned that the consumption function is 50 plus 0.75 times disposable income. So this autonomous component of consumption, which is here abbreviated with C0, is in the numerical example equal to 50. And the marginal propensity to spend, C1, is equal to 0.75. The investment function is equal to 150 minus 10 times R. So the 150 here symbolize the autonomous component of investment. And this minus 10 indicates that here our parameter B1, the interest rate sensitivity of investment, is equal to 10, or like minus B1 is equal to minus 10. Government spending is exogenous, equal to 250, and taxes are equal to 200. So we have specified all the information of the IS relationship. Then on the money market, the right-hand side, like money demand, liquidity demand, is equal to 50 is equal to Y minus 50R. So D1 seems to be equal to 1. Changes in GDP change money demand on a 101 level. D1 is equal to 1. And then minus D2 is equal to minus 50. So D2 is equal to 50. Nominal money supply is equal to 3,000 and the price level is equal to 4. Now we can insert all the numbers we have into the IS and the LM relationship. And when we do that, we get to this two equations. So the IS relationship, 50 plus 0.75 times Y minus taxes, disposable income in brackets. This is the consumption function. Then we have here our investment function. And this part is government spending. So in equation 30, we have on the left-hand side real money supply, the nominal money supply divided by the price level. And on the right-hand side, we have liquidity demand. There we have the real demand balances for money, the 50 minus 50R. Money demand depends in a positive way on GDP and in a negative way on the interest rate. Now you can see that in this equations 29 and 30, it is the case that only two unknown variables are left. Y is an unknown variable and R is an unknown variable. So when we have two equations and two unknown variables, it should be possible to solve for the unknown variables, which implies that by these equations, we are able to solve for the equilibrium interest rate level and the equilibrium level of income. So this will be one task in your exercise class that you have to solve for the equilibrium interest rate and the equilibrium GDP level. So let's try to get the big picture again. We used the Keynesian cross to derive the IS curve and the theory of liquidity preferences to derive the LM curve. The first step occurred in subchapter 11.1 and the second step in subchapter 11.2. Then we combined the IS curve and the LM curve, and it is the case that we get to know the IS-LM model. We did not work with the IS-LM model yet, but the model is now ready so that we can analyze what happens if the one or the other change happens, how is this shock digested, what about the interest rate and the GDP level, like how do they change in case that the one or the other exogenous variable changes. We use the IS-LM model to look at the aggregate demand curve. So the IS-LM model in the end will determine aggregate demand. We can bring aggregate demand and aggregate supply together, and then we get this model of aggregate supply and aggregate demand, and we can in the end explain short-run economic fluctuations. Thank you very much for attending this lecture. Have a nice day. Bye-bye.